Hey guys! So today we're going to take a look at finding all of these solutions. So we're going to continue on our journey to finding all of the answers, similar to what we've already done, but the examples today are going to look a little bit different in terms of how we go about solving them. So you need your notes. You're also going to need a graphing calculator. You have an app on your phone, so you're going to need that. I'll refer to that. I'll already have it graphed for you since some of you are probably watching this video on your phone. And also you're going to need something to write with, obviously. So take good notes. I have been talking about finding the zeros. So in order to find the solutions, what are the steps that we go through to make that happen? So please take a minute and write these in your notes. This kind of summarizes what are the things we've been doing in the last few days. We've been getting a hint to get started. So we need to figure out a way to get that number on the outside of our synthetic division to get this thing started. We then set up division and we find the quotient. And then we can factor the quotient if possible. And in the end, we want to make sure we find and list all of the solutions that we're looking for. So these are the steps that we've been going through. Now, all along, you've been kind of having some understanding or thinking about this fundamental theorem of algebra. And I've hinted to this, but we never gave it a name before. Just like geometry has the Pythagorean theorem, algebra has the fundamental theorem of algebra, this big idea that all the solutions, the total number of solutions a polynomial has, is equal to its degree. So that means the highest power you see is going to tell you how many solutions you're looking for. You already knew this. This is no surprise. What we have seen and what we will continue to see is that the solutions can take many forms. All of these forms could happen. They could be integers, fractions, square roots, irrational, double counted, and even imaginary, if you can imagine that. So all of these things could happen in terms of finding those solutions. So the examples we're going to look at today have some different answers than the things we've been talking about before, and that's why we're going to take some time and go over just these. So here's the first example. Write this one in your notes. This is a function f of x equals x to the third plus 5x squared plus 4x plus 20. So already, right off the bat, we know we should be looking for 3 solutions. And we're supposed to solve and find all 3. Now, to find those 3 solutions, we've been talking about getting a hint or figuring out how to set up that division to get it started. So we would set up the division, and we put 1, 5, 4, and 20 in there. And we're going to divide out something that we know is a solution, or we can kind of guess is a solution if we use the p's over q's. But we've been talking about how we can use our understanding of graphs to help us out. So if I were to graph this, and I graphed it on a graphing calculator on my computer here, this is what the graph looks like. You could type this into your graphing calculator app and generate a similar graph. It would look exactly the same. But we know that we can use what this graph is showing us to get a good hint. So according to this graph, -5 is a good solution for us to use to get it started. Now remember, this guy is supposed to have 3 solutions, right? I only see one spot on this graph where he crosses the x-axis here. So I only see visually one solution out of the 3 that I'm supposed to have. This is rather weird. This has not happened before. So why don't I see those other 2? That's kind of weird. Let's figure out what's going to happen here. I'm going to use that -5 that I know works, and I'm going to divide him out. So I'm dropping down the 1, -5 is what I get when I multiply, add 0, multiply 0, add here 4, multiply -20, yay, okay? We knew that this was going to make a 0 remainder because we can see obviously that he is a solution. So what's left after we divide out our hint? What does that mean for this stuff right here? Well, 0 is my remainder. 4 is the regular number here, my plain number. 0 would be my x's, and 1 would be my x squared. So what I have is x squared plus 4 left. So can I factor that? No, if that was a -4, I could. But the fact that it's x squared plus 4, it's not a difference of perfect squares, so I can't factor it. So how do I find those solutions that I can't see on the graph here or can't figure out? Well, I take this thing that's left here, this x squared plus 4, the quotient, and I need to solve him. I need to set him equal to 0 to find his solutions. So I'm going to subtract the 4, X squared equals negative 4. I'm going to square root to get the x alone. Square root of negative 4. Square root of 4 is 2. The fact that it's a negative tells me that's right. I'm going to have imaginary answers. You guessed it. There needs to be an I. Okay? So my solutions, two of them, are plus or minus 2i. So I have two solutions here that I can't see on a graph because they're imaginary. Go figure. So that's why we have to know how to do this by hand, because not everything can be done on a calculator, okay? So I have two solutions that I figured out. Where's the third? Because I was supposed to have 3 here. That's right. The negative 5 that we used to get this thing started is my third. So my 3 solutions are plus positive 2i, negative 2i, and negative 5. Okay, so we use the graph to get this thing kind of going so we can figure out what's going on. Let's take a look at another example here. Next one. Second example, function f of x equals 3x to the fourth plus x to the third minus 10x squared plus 2x plus 4. Okay, so like we did before, we know we're going to divide this out. We're going to divide some solutions out to get it started here. So 3, 1, negative 10, 2, 4, and using our understanding of graphs, if we were to graph this so I can get a feasible rational zero here, or get a hint off the graph, I'm going to take a peek. This is what my calculator looked like when I did it on my phone. And I'm going to steal one from here. I think I'm going to take that one right there. Looks like he's crossing at positive 1. So I'm going to take that and use that to get me started. So 3 drops down, multiply, add, multiply, add, multiply, add, and one more multiply, and add. And what should happen, of course, you know you are taking a good rational zero from your graph. If you get a zero remainder, that's a nice thing. So what's left here is if I put my x's back on here and I kind of label what's going on, the negative 4 is my plain number, my constant. The x's would be here, x squared would be there, and this one would be x to the third. So this is the polynomial that I have left after I divide out one of those solutions. Well, notice he still has a 3 power on him here. So I need to keep dividing until I get it down to a squared so that I can maybe factor or do something else with it to solve. So I'm going to set up division again and take another one off this graph. Let's see, I don't know exactly what spot that is. It could be a half, but I'm not sure. So I'm going to go with negative 2 here because I see that he crosses the x-axis there. So negative 2, and now I'm going to place my polynomial that I've worked down so far, this guy right here, into that division. And you don't need the x's again, just the coefficients. And so we'll divide one more time. So dropping down the 3, negative 6, negative 2, 4, negative 2, positive 4, hooray, hooray, 0. Okay, so what's left here, if I was going to label these back with x's again, negative 2 is my constant, negative 2x, and then 3x squared. Nice, so that's the function where I have him left so far. So I got him down to an x squared. I know I'm supposed to have 4 solutions total. I can see that this part, if I solve just this red part right here, he's going to give me 2 of my 4 solutions, so I need to keep going. So how would I solve this? Well, you go, hey, maybe factoring, maybe AC method. 3 times negative 2 is negative 6. What multiplies to make negative 6 and adds to make negative 2? Uh-oh, people. It's not looking too good. There's nothing that does that. So then what do I do if I know I have to find those 2 more solutions from this part of the polynomial here, and I don't factor? What could I do? Well, I still have to put equals 0 after him and find a way to solve. And that's right. It's quadratic formula time. You weren't thinking that, were you? I think you were. You were thinking it. Because I cannot factor, I still need to find two solutions. The only other option I have when I cannot factor is I have to do quadratic formula, or I guess I could complete the square, but that wouldn't be too fun on this one. So maybe I better use my quadratic formula. I'm going to write it to the side right here. Negative b plus or minus square root b squared minus 4ac all over 2a. And if you want to, you can wrap that out in your head. You know what I'm talking about. We're going to go ahead and plug this guy in here. So according to what I have so far in red right here, I'm going to use the quadratic formula on this guy to get my two solutions. Negative of the b, so I'm going to use 2 plus or minus square root. The b thing squared, that would be 4, because the b is a negative 2 right here. And then subtract 4 times the a number, 3, times the c number, negative 2, all over 2 times the a, which is 3. Now I just need to simplify this, calculate it, so I can figure out what those two answers are. So continuing on, 2 plus or minus square root. Now I'm going to go and calculate all this underneath that square root sign. 4 subtract 4 times 3 times negative 2 is, that's right, 28. All over the bottom is 6. 2 times 3 is 6. So square root of 28. What's that? Well, we'd want to simplify that, people. This becomes 2 plus or minus 2 square roots of 7. 4 times 7 makes 28. All over 6. And we want to simplify. I'm going to divide a 2 out of all those things right there. Can't touch a square root of 7. So I'm going to divide a 2 out of everybody there. So it becomes 1 plus or minus 1 square root of 7 over 3. So x equals that stuff right there. How many solutions is that? Well, that's technically 2. 1 plus the square root of 7 divided by 3, and 1 minus the square root of 7 divided by 3. That's 2 solutions. Where are the other 2? Oh yeah, way back! When we got started, we took a couple solutions off of that graph. Don't forget about those two. X equals 1, x equals negative 2. I have 4 solutions. I needed to get 4 according to the fundamental theorem of algebra, and I did that. So this is an example of when you may have to use a quadratic formula if you can't factor. Most of the time we can factor, but sometimes we have to pull out another trick from our bag and be able to figure out what's going on. So be prepared. We're going to continue on finding all of these solutions using whatever methods we need to in order to find those 4, 5, 6 answers, whatever the problem has. Okay? Thank you for taking good notes, and I will see you.